Hello, my dear student. I am Aditya Chakraborty, lecturer electrical engineering of Sri Ramakrishna Institute of Science and Technology. So today we are going to discuss about the DC 3-point and DC 4-point starter, which are mainly used in DC shunt and compound motor. So before going to the deep study, we have to know what is the necessity of starter or why we are going to use the starter. So you know the basic operational voltage equation of DC motor is given as V equals to EB plus IARA. We have seen here that V equals to EB plus IARA. So EB equals to V minus IARA or IA equals to V minus EB by RA. So here V is the supply voltage, EB is the back EMF or the EMF induced in armature of the DC motor due to the generator action. RA is the armature resistance and IA is the armature current. And we know the value of RA, a standard value of RA or armature resistance is 0.5 ohm, and the standard supply voltage or rated voltage of the motor is maximum 230 volt or 250 volt. So we are considering here the supply voltage is 230 volt. That means the V equals to 230 volt and the armature resistance is 0.5 ohm. So now when the motor is at starting condition or is at rest condition or initial condition, when it is in standstill mode, the value of back EMF is 0 because there is no speed in the motor or motor is in the static condition. So no flux is cut by the armature of the motor. Hence the armature current at that moment of starting can be given as IA equals to V minus RA because this part EB equals to 0. So IA equals to V minus RA. So the value of V, we are considering that 230 volt and the value of RA is 0.5 ohm. So then the value of IA is 230 by 0.5, that means 230 into 2, that is 460 ampere. So in practically in DC motor the armature resistance is very low. We know that 0.5 ohm. So therefore a large current will flowing through the armature circuit during starting, that is 460 ampere. Can you imagine how much the value? And this current is large enough to damage the armature circuit. And due to this excessive starting current, what will happen? The fuses may blow out and the armature winding or commutator brass arrangement may be get damaged. Due to very high starting torque, if there is no damage occurred in the armature winding or brush, so what will happen? Due to high starting torque, there is a high centrifugal force is produced, and for that very reason the armature winding are thrown off from its core, and also other loads connected to the same source may be experienced a dip in the terminal voltage. So we can't supply the rated voltage directly to the armature of the DC motor till the full back EMF is not generated. So we have to increase the voltage gradually, or at first we have to supply a reduced voltage, and when the full back EMF is generated, how can we know when the back EMF is full? When the motor is running at its rated speed. That means at that time the full back EMF is generated, and at that time we can supply the rated voltage to the armature of the DC motor. So that is the necessity of starter. And in our study we are going to discuss the 3-point and 4-point starters. So these starter are mainly used to supply the reduced voltage and to gradually increase the voltage towards the rated voltage. And apart from that, the starter is also used as a protecting device. So at first we are going to study the 3-point starter. So here you can see the 3-point starter circuit diagram. You can see here the R1, R2, R3, R4, R5. These are the resistance and which are connected in series with each other. These are the resistance, and here is a soft iron piece is connected with the starter handle, and a spring is provided here. Okay, and here you can see a coil that is known as overload release coil, and there is a lever, and that is a triangular iron piece, and there is a field winding. This is the armature winding connected in this point, and the field winding is connected in this point. That is known as the no volt coil, and that is the line which is connected with the DC supply, and this is the double throw switch. This is the double throw switch. So 3-point, that means there are 3 tappings are used. So these 3 tappings are L, F and A. So here you can see 3 tappings. One is line, that is L. One is field, where the field winding of the DC shunt or compound motor is connected, that is field. And one is armature, where the armature of the DC motor or DC shunt or compound motor is connected. So here are 3 numbers of tapping, so it is known as 3-point starter. And this DC supply is connected with a double throw switch. So when the double throw switch is on, that means the plus and minus are connected. At that moment, a current will flowing through this path. And after that, it is flowing through this handle. And when this handle is manually moved to the first start, this 1, 2, 3, 4, 5, these points are called starts. Okay, so when it is moving in the number 1 start, what will happen? The current is divided from this node into 2 parts. One is supplied through this R1, R2, R3, R4 and R5 resistance to the armature, and another is supplied through this path by energizing this coil, no volt coil. It is supplied to the field winding. So we can see here, when this handle is manually moved to the first position, then the voltage is reduced by the help of R1, R2, R3, R4, R5 resistance. So a reduced voltage is supplied to the armature, and maximum current which is supplied to the field through this coil. So when from this one point it is moved to the run point step by step by 2, 3, 4, 5 and the run point, at that moment the maximum back EMF is induced, and the motor will, the armature of the motor will supply the maximum rated voltage. So when that is this handle at run condition, so the maximum current will flowing through this path to the armature, and the minimum current will flowing this path through this path, that means from R5, R3, R2, R5, R4, R3, R2, R1 resistance and to this path, and it energized this coil, and after that it is supplied to the field. So the field current is reduced and the armature current or the armature voltage is increased. So the primarily the main function of the starter is to supply the regulated voltage to the armature of the DC shunt or compound motor is achieved by this system or by this device. Now the function of the no volt coil is, when this handle of the starter is at that position, run position, by the help of the field current which is supplied to the field, this no volt coil is energized or magnetized. So it attached this starter handle, okay, at that position, and this at that position the motor is running at its rated speed. If the overload is occurred, now we have to know what is the function of the overload release coil, spring, lever, and these two conductor. So if the overload is occurred, then the current which is supplied to the armature is increased. So that means the value of the armature current is increased. And when it is increased, then this overload coil or overload release coil is energized. And when this is energized, then there is a magnetic flux is produced, and which pulled this lever, and the lever is from this position to upward position. And here you can see there is two conductor, one is connected here, another is connected here, and so these two conductor are made a common terminal here. So when this lever is pulled up, then the triangular iron piece shorted these two terminals. So what will happen? At that moment, the current which is flowing through the NVC coil and supplied to the field, it will bypass the NVC coil. Due to the short circuit path, it will flowing through this path and short circuited it, and after that it will flowing from this path and supply the circuit, and it is supplied to the field winding. So it is bypass the no volt coil. So if this coil current, any current is not flowing through this path, then it is demagnetized, and hence the attractional force is 0, and by the tension of the spring, the starter handle has come to its off position. That means the motor is disconnected from the supply. So by this coil, it is protect, or it will protect the motor from the overload current or from the huge current and from the damage which is caused by this overload current. So that is the 3-point starter. So you can see here the explanation. When the connected DC motor is to be started, the lever is turned gradually to the right, and when the lever is charged in point 1, the field winding gets directly connected across the supply, and the armature winding gets connected with the resistance R1 and R5 in series. During starting, the full resistance is added in series with the armature winding. Then as the lever is moved further, the resistance is gradually cut up and from the armature circuit. So it can be seen that when the arm is moved from the position 1 to the last position, the starter resistance get added in series with the field winding, but as the value of the starter resistance is very small as compared to the shunt resistance, the decrease in shunt field current may be negligible. However, to overcome this drawback, a brush or copper arc may be employed within 3-point starter, which makes a connection between the moving arm and the field winding, as shown in the figure of the 4-point starter below. So there is a disadvantage of 3-point starter. So what is the disadvantage? We already know what is the working principle of the 3-point starter. So by the help of 3-point starter, the gradually increasing of voltage is achieved. But if the speed of the motor is increased to is overrated speed, we can't use this 3-point starter. Why? You can see here that if we want to increase the speed above the rated speed, what we have to do? We have to connect resistance at its field or variable resistance in series with its field, and if we decrease the field current, then the speed will increase, or if we decrease the field flux, then the speed will increase. So if we connect resistance with a series with the no volt coil, what will happen when we uh, want to increase the speed of the DC motor above its rated speed? What will happen? We have to reduce the current or reduce the field current. So when we reduce the field current, then the current which is flowing through the NBC is reduced also. And we know the field resistance of the DC shunt motor or DC compound motor is very high. So at first this current which is supplied to the field is very low, and if we connect a variable resistance series with the NBC, what will happen? This current is practically negligible. At that time the no volt coil is demagnetized, and the due to this spring action, the handle or the starter handle is back to its rest position, or that starter is off. So we can't achieve the field control, or we can't rotate the motor above its rated speed by the help of 3-point starter. So we have to design the 4-point starter, DC 4-point starter. So what is 4-point starter? You can see here the diagram of 4-point starter. This is same as the 3-point starter, but here is the only difference is that you can see here in the 4-point starter there is a parallel connection between the field winding and the NBC. So the conductor which is connected that in that first stud or one number of stud is connected with NBC in parallel. So from this node, two parallel circuit is produced made. One is connected with the field winding through a variable resistance, another is connected with the no volt coil, and by which very high resistance is connected with this no volt coil in series. So what will happen if we want to rotate the motor above its rated speed? We have to control the field current which is supplied through this path, and if we reduce the field current, or if we decrease the field current, then the speed will increase. But there is no dependency. This current is not dependent with the current which is flowing through the NBC, because if we consider that I current is flowing through this path, and one is I1 which is supplied to the field, and another is I2 which is supplied through this NBC coil to the resistance R. So if it is reduced, then the value of this I2 current, if I1 is reduced, if we increase the resistance, if we increase the variable resistance which is connected in series with the field winding, then the I1 current is reduced, and hence the I2 current is increased. And if the I2 current is increased, then more number of magnetic flux is produced in the NBC coil. So there is a attractional force is increased. So the field control is achieved by this 4-point starter. And when to supply the more number of current through the NBC, we have to connect here a high load resistance. If the load is increased, the value of current is also increased. So there is a 1 kilo ohm resistance is connected, and which also reduce the heat, or this resistance absorb the heat which is produced due to this high current which is flowing through the NBC. When the field current is reduced, then the value of the current which is flowing through the NBC is increased, okay, and which is supplied to the high resistance R. So here we can see the 4 number of tappings. One is L or line, one is A or armature, one is field, that is F, and the last tapping is the tapping with the high resistance, that is the R. So here L, A, F, R, 4 tappings are in the 4-point starter. So it is known as the 4-point starter. So that is the working principle of 4-point starter. So the explanation, the main difference between 3-point starter and 4-point starter is that no volt coil is not connected in series with the field coil. The field winding gets directly connected to the supply as the lever moves touching the brass earth. Touching the brass earth, the no volt coil or no voltage coil is connected with the current limiting resistance RH or high resistance, and which is above 1 kilo ohm. This arrangement ensured that any change of current in the shunt field does not affect the current through the hold on coil at all. This means, or no volt coil at all. This means the electromagnetic pull of the hold on coil will always be sufficient to that the spring does not unnecessarily restore the lever to its off position. So that means in that case the motor will remain rotating at its overrated speed. A 4-point starter is used where the field current is to be adjusted by means of field rheostat for the purpose of operating the motor above rated speed by reducing the field current. Okay, so that is the working principle of field current 4-point starter. Now the comparison between two types of starter. So definition, the starter which uses the 3 terminals for starting the motor or 3 tapping, that is known as 3-point starter, and the 4-point starter used 4 terminals for acceleration of the motor or to rotate the motor above its rated speed. Terminals, armature terminals, field terminals, and the line terminals, that is A, F, and L. And in case of 4-point starter, there are 4 terminals, that is armature terminal, field terminal, line terminal, and the additional terminal they are directly connected to the supply of the no volt coil with the resistance R or high resistance R. And basis of comparison, that is the no volt coil connected in series with the field coil and connected in parallel in case of 4-point starter with the field coil. So that is the comparison between two types of starter. That's all. Thank you.